Hello. Today we're going to be working on factoring quadratics. We're going to be doing some applications and then also some extensions along with some review of your vertical motion model. So let's take a look at number one. We have Stephanie in a snowboarding competition. She's jumping from a height of 10 feet and an initial velocity of 30 feet per second. We want to write an equation to represent her height over time. So the vertical motion model is going to be h of t equals negative 16 t squared. So that part is constant due to gravity. It's plus the initial velocity. So her initial velocity here is 30 t plus the initial height, which is 10. We want to know how long Stephanie will be in the air. So if we are visual, so here we go. She would be starting about here, jump into the air, and then land. So right here is when she lands. So for part B, we are looking for the 0. So what we're going to do is we're going to type this into y equals. So we have our equation. We're going to go ahead and graph it. And we're just going to calculate what this 0 over here is. This is not going to be factorable or very nice. So you can just hit second calculate, your 0, do your left bound, right bound, and hit enter for your guess. And you should get 2.16 seconds. Part C, when will Stephanie reach a height of 15 feet? So looking at this graph, if she started off at 10 feet, 15 feet would be here. So she's going to reach it once on the way up and then once on the way down from her maximum height. So what we can do is we can say our initial equation was negative 16t squared plus 30t plus 10. Our second equation here is going to be when her height is 15. And what we're really looking for is the intersection of the two. So we can go back to our graph and we can go ahead and we can plug in 15 feet as her height. And so you'll see that visual pop up. And so you can now go ahead and hit second calculate. We want to know the intersection of those two. So that will tell us when her height was 15. So you're going to go ahead and do that once to calculate this first one. Oh. And that first intersection is going to be 0.18 seconds. And then go ahead and do it again. So you do second calculate the intersect, and then you hit enter 3 times. After going close to this point over here, you should get 1.69 seconds. So she hits 15 feet once on the way up and once on the way down. So we want to now calculate if she's able to get her bonus points by reaching a maximum height of 20 feet. So this point right here, we don't know if that point is going to exceed 20 feet or not. So there's many different ways we can do this. We can type in y equals 20 and we can see if those intersect. Or another way to do this is to calculate the maximum height. Okay, I'm going to do it this way just to do a good review of all the different stuff for quadratics so far. So what we can do is we can go ahead and find the vertex. So we can do x equals negative b over 2a to get 0.94. We're going to take 0.94 and we're going to plug it in for your time. So plug in 0.94 for t in both of those places. And you're going to get 24.06. This represents your maximum height. So since that height is more than 20 feet, then yes, she would earn her bonus points because she got up to 24 feet and she only needed to get up to 20 feet. So again, many ways to do that. You could have typed in 20 for your y2 and see if those equaled each other, but this is just another way of doing it. So we're going to move on to some factoring extensions now. So we've done all of our different methods of factoring. Now we're going to look at these where now more than one thing kind of applies here. So let's take a look at 2a. We have 4x minus 1 squared minus 9. Now, looking at this, it looks pretty messy. We could write 4x minus 1 twice and square it and subtract the 9 and then factor, but that's a lot of work. So wouldn't it be nicer if this problem had just said a squared minus 9? We're going to let a equal 4x minus 1. Because if this here, 4x minus 1, were just an a, you would normally look at that problem and you'd say, wait a second, I can factor that. That's just going to be a minus 3 and a plus 3. This is the difference of two squares. So the only difference then is instead of a, we're going to write 4x minus 1. Okay? So this first term is going to be 4x minus 1 minus 3. And then 4x minus 1, oopsies, plus 3. Notice, we're still doing the difference of two squares. We're square rooting the first term, we're square rooting the last term. We're writing one with a plus and one with a minus. It's just that the first term is a binomial. Because now, in order to factor or simplify this, we have to continue on with our parentheses here. So I have 4x minus 4 when I combine like terms, and then 4x plus 2. So I'm almost done factoring, but now I have a GCF in each one of these. So in my first parentheses here, I can take out a 4, and I'd be left with x minus 1. In my second set of parentheses, I can take out a 2, and I would be left with 2x plus 1. And the 4 and the 2, the GCFs, we can take and multiply them to get an 8 on the outside, x minus 1, and 2x plus 1. So this extension shows us that we can now factor things that don't just have a nice term like a or just an x. We can factor things that are written in terms of other things by using a little bit of substitution. Now we will practice this more tomorrow and upcoming because this is a brand new scale for us. Now how about b here? So looking at this, we have x minus 9 times the square root of x plus 14. So looking at this, this also looks different than anything we've seen before. Now, let's just enter pretend land over here. Let's pretend this is u squared minus 9u plus 14. If you're looking at this, you'd look at this and say, well, what multiplies to get 14 but adds to get negative 9? You'd say, well, negative 7 and negative 2. You'd look at that and without a second thought, you would go ahead and factor it. Now, the only difference with this one is that we're still going to have the minus 7 and the minus 2, but my first terms have to multiply to get x. So it's not going to be like x and x because it doesn't work because that would give you x squared. So instead, if I write the square root of x and the square root of x, those would multiply to get me 1x, and at the same time, the middle term would then remain the square root of x. So this middle term here can help guide you when you are factoring things. Now for part C, now we have x to the 6th power. The only thing, there's no GCF with this, so the only thing we can check is this the difference of two squares? So can it be written as something squared and something squared? And yes, x cubed and y cubed, when you square them, gets you to the 6th power. So what we can do is x cubed minus y cubed and x cubed plus y cubed. So we're able to use the difference of two squares with higher powers. So those are some extensions. Now what we're going to do is we're going to take and work backwards. So we have the roots or the zeros or the solutions of x equals 2/3 and x equals negative 5. We want to write the equation and we want it to be in standard form. So what we want to do is we want to take these and we want to work backwards and say, well, if these were my answers, what would the factors have been? So x equals -5, let's tackle that one first. So if that's equal to -5, normally my factor would have been x plus 5, because I set my factor equal to 0 to solve that. Which then stands to reason that the next one would be x minus 2/3. But we can't have fractions in there. We've never really had a fraction in there. So therefore, what we have to do is we have to adjust a different way. So normally what we could do, or what we would do, is we would take and divide to get it to be a fraction. So to work backwards, we're going to write it as a coefficient. So that's going to be a 3x minus 2. Now if you don't believe that, go ahead and set that equal to 0. You would end up with 2/3. So if you ever try something and you're like, I'm not sure if that should work, you can always set it equal to 0 and solve it. So now to write it in standard form, all we have to do when writing it in factored form is go ahead and distribute. So we get 3x squared, we have 15x minus 2x, so that's 13x minus 10. When in doubt, take it in factor. See if you actually end up with the same zeros that you were supposed to. So now we have a couple of application problems here. We have two consecutive even integers. So we're going to call our first one x. To make it even, we're going to have to space it out every 2. So numbers like 2, 4, 6, 8, they're all 2 apart. The product has to be 10 or 1088, so we're going to take our first one and multiply it by our second one to get 1088. So go ahead and pause the video, solve for x, and answer the question, and we'll reconvene in a moment. So after taking a moment to go ahead and solve for x, we end up with getting x equals -34 and x equals 32. So with this one, what's happening here is there's more than one thing that would work. So if x is -34 and I plug in -34, I would get -4 and -32. But if I were to take and plug in 32, I would get a positive 32 and a positive 34. These both work because they multiply to get a positive 1088. So the last problem here is the infamous border around something problem. So you have a garden, it's a rectangular garden, it is 20 by 25. We want a pathway to be installed around it. But the problem is we don't know the width of the pathway. All we know is it's going to be a uniform width all the way around. So what we can do is we can call that pathway X. The total area is going to be 750 square meters. So now the problem is to find the area, you have to do length times width. But we don't know our new length or our width. So looking at this, originally my width was 25, but I'm extending it by x on both sides. So overall, I'm doing 25 plus 2x. The other one was 20, but I'm once again extending it by x on either side. So my new width here is going to be 20 plus 2x. So if I were to do length times width of my new length and width, I should get a total area of 750. So let's go ahead and distribute this and solve this. So once you distribute it, you get everything on one side. There is a GCF. And then from here, you can continue to factor. Ooh, I dropped my 5. Whoops. Okay, so we get x equals 5/2 or -25. So in this problem, the negative just doesn't work with the context. So the width would be 2.5 meters for that border. So thank you very much for listening. I hope this helped. We will go over any questions you have tomorrow.